In this video for section 2.6, we're going to talk about composition of functions. Composition of functions is a way of putting two functions together to create a new function. So let's think about this scenario. A store is having a sale. They're offering a $15 off the purchase of 4 video games and 10% off if you're a first-time customer. The discounts could be applied in two different orders. We could do the $15 off first and then take 10% off the remaining price. Or we could do the 10% off first and then take $15 off the remaining price. Which do you predict would save you the most money? So you might think that it doesn't matter what order we apply the coupons, but it actually does. So if you think about it, if we do the $15 off, it's going to take $15 off regardless of when we apply it. But 10% off, the more that we're spending, the more money we're going to get off of our price. So if I spend $100, that's going to be $10 off. If I spend $200, that's going to be $20 off. So we want to use that coupon when the price is the highest. And in this case, that's going to be before we use the $15 coupon. So you would save the most money by using the 10% first, since you are taking 10% of a larger amount. So let's check ourselves here. We want to calculate the sale price of $85 worth of games when the $15 off discount is applied first. So first we're going to take $15 off. And if we're spending $85, then our remaining price is going to be $70 once we do that. And then we want to take 10% off of that. So 10% of 70 is 7. So we are taking $7 off that $70 price, which is going to leave us a price of $63. Now we're going to do it the other way around. Apply the 10% off discount first and then the $15 off. So 10% of $85 is $8.50. So if we take 85 minus 850, that's going to leave us with a price of $76.50. And then we take $15 off of that. And that gives us a final price of $61.50. So it is in fact going to be a better bargain, going to save us the most money, to use the 10% off first and then take the $15 off of the rest. So it does matter what order we apply the coupons in. And this is an example of a composition of function, where we first carry out function g and then carry out function f on the result. So in this case, our first function for number 2 was subtracting 15, and our second function was taking 10% off of the result, or multiplying the current purchase price by 0.9. So what we're going to do when we do a composition of functions is we input into function g first, and then we get our output that becomes the input into function f. The notation for this looks like this. There's two different ways that it's written. One is with sort of nested parentheses. This is f of g of x is how we would say it. This one is with the circle, f of g of x, pronounced the same way. And the important thing to know here is that when you're doing f of g of x, you are plugging x into g first and then into f. So it works from right to left or from inside to outside. So based on what we saw in our previous situation with the video game discounts, does order matter when composing two functions? I would say yes, order does matter. Because you get different answers or different numbers depending on the order that you use.